Hello, my name is Cano, and I'm the CEO of Carbon Power Mexico, where we are turning pollution into profits. We already know the global challenges that we have, and different industries are producing a lot of tons of CO2 each year. And it's a great opportunity because we have seen the problem right now is that companies are spending more than $1.1 billion per year to only avoid, not even reduce or remove, to avoid their carbon emissions. And we have found a solution where we are removing these emissions and transforming them into something useful. This is a Ceal unit. A Ceal unit is basically an equipment that we install as a point source carbon capture device that is transforming these emissions into fuels, biochar, and other materials. We're already working with the ceramic industry and soon with the glass manufacturing industry. We're already making revenue each month, and they're not paying more taxes, and also have a ROI of 5 and 4 years. Our business model is basically carbon removal as a service, as we lease the equipment to these companies so they can be paying less and not the whole full capex at the beginning. We commercialize the substances, and then we also creating the carbon credits. These are the substances that we can produce: biochar, methanol, ethanol, ethylene, formic acid. But basically right now we're only working more with biochar and ethanol. We focus on the ceramic industry because it's not a hard industry to decarbonize. It's not one of the biggest emitters, but it was a great proof of concept for us to start in a small company that is based in Mexico State. We are working with some companies like Cemex, Grupo Cementos de Chihuahua, in order to scale up the process that we already have in Mexico State. We have been through several accelerator programs, and our clients right now, it's Ceal Orozco and Cerámica Santa María. The founding team has experience in different areas like electrochemistry. My COO, Bernardo Mejia, it's also a chemical engineer as myself, with experience in different industries, such as also like Rodrigo with experience in financing, and Eduardo Gonzalez with experience in research. We already have very good advisors that have been teaching us and leading us towards the minimum valuable product, which is the Ceal units. So this is our main objective and our main goal, to have 10 of these units operating. Pretty much like this is like what we are looking for the next years, and this is the potential. Basically, I like to put it this way: we're removing like indirectly 41,000 tons per year. And thank you very much. Let's decarbonize the world with our solution. Thank you very much.
Thank you very much for the presentation. Can you please explain more of a competitive edge of your technology?
Sure. Our competitive advantage is that we can operate at high-level temperatures. So other technologies like amines need to be cooled down and then heated up again. So we're like saving 90% of that OPEX. So we don't need to do that. Our competitive advantage is basically that we can operate at high-level temperatures. And that's a cost of production of OPEX of 90% compared to other industries or other technologies.
Perfect, thank you.
Hi, thank you. Can you talk about the payback period of one of the units, just to understand with the leasing model, how quickly that gets paid back?
Yeah, we do a sharing revenue model, like with the company. So they will be getting the money back for the profits that we are making by the commercialization of the substances that we produce. We already have everything sold out of the substances that we produce. So that's not the biggest problem. The problem is always like getting the money back. So we have this model just to pay the capex of the equipment, but as we are creating revenue with the substances that we're producing in situ.
Hi, thank you. Could you please tell which next domain you're going to go after ceramics?
We're going towards the glass industry. Why? Because it's a very similar exhaust or like gases that they have. The only difference is that they operate 24/7, not in batch as in the ceramic industry now. Okay.
Any more questions? 10 seconds to go. Anything else to say?
Thank you very much for having me here. Thank you, Bilbao.
Congratulations for your pitch. Thank you very much. Continuing with Matti Shani, co-founder and CEO of Ceal Minerals Ltd. There you are.
Thank you very much. Okay, good morning. So Ceal is a carbon dioxide removal company, and we do so while increasing the efficiency of seawater-cooled thermal power plants. Power plants have a problem that Ceal easily solves. The cooling pipes of the power plants are clogged by biofouling and scale, as can be seen in the picture. The cause for both is the abundant calcium found in seawater. To reduce this problem, power plants use hazardous chemicals today, and this is something that we're going to abate. Ceal's patented carbon negative process transforms carbonates and calcium from the seawater into precipitated calcium carbonate. This creates calcium-depleted water that, calcium-depleted water that solves the problem. Moreover, we create high-quality and high-value carbon-negative minerals, and we capture and sequester atmospheric carbon dioxide. So, multiple benefits in a single process. For an average-sized power plant, we increase production efficiency by 4%, saving millions of dollars annually. We boost annual revenues by over $100 million from selling the minerals, and we remove 500,000 tons of atmospheric carbon dioxide annually. We create an end-to-end profitable industrial value chain. Power plants enjoy a remarkably short return on investment. Mineral producers receive cheaper and carbon-negative minerals, and Ceal benefits from rapid scaling, asset-light operations, and major royalties. The Israeli Electric Company provided us with a letter of intent to build and operate a funded pilot at their largest power plant. Jiménez, a world leader in the production of precipitated calcium carbonate, provided us with a letter of support to become a future off-taker. There are 1,100 seawater-cooled thermal power plants globally, which is equivalent to 10% of the entire CDR market. Working with all these sites, Ceal becomes a gigaton CDR operation. We use prototype scaling in order to generate early revenues. Industrial sites such as regasification, chemical plants, or refineries will be our first commercial installations, then move to small power plants, and finally to larger ones. Ceal's technology was developed at the Technion, the Israeli Renowned Institute of Technology. And we raised over $1 million from VCs and a non-diluting grant from the Israeli Innovation Authority. We seek additional $2 million. If you're interested, let's talk. This is the beautiful view from our office. Thank you very much for your attention.
Any questions?
Thank you very much for your presentation. Does your technology produce any tradable carbon credits?
I'm sorry?
Does your technology produce any tradable carbon credit?
So we want to avoid carbon credits. The whole purpose of us is being a profitable company without relying on carbon credits. We sell minerals for a lot of money, much higher than the carbon credits.
So thanks for the presentation. If I got it right, your revenue streams mainly depend on the minerals you're selling, and there was just this 3 million contribution from the operating benefits. So why is this in the first place connected to putting this in front of a power plant?
So the power plants will own the minerals. So they will sell the minerals. We will support with creating the entire value chain. This is the reason why I said we work already with Emil to be the off-taker. We will connect all the dots. They will get the revenues, we will take major royalties out of that. And this was already, the validation of the business model was already validated with 7 utility companies.
Thank you. What are the major barriers do you see in the implementation and deployment?
2. First, from the prototype that we have today, which is a TRL 5, we work already 5 months with seawater. We need to scale up by 6 orders of magnitude, 1 million. It's a pretty big challenge. And the second is that we're innovating in a way the energy market with a business model. There are some aspects of royalties there, here and there, but to create all that, creating the minerals, sustainable minerals, and selling them, this is something which is a little bit novel. Again, all the utility companies said it makes a lot of sense for them because of the revenues, but it's new.
Thank you very much. That will be all for today.
Thank you.
Congratulations for your pitch. Next one on stage, introducing Scott Larson, CEO of CO2 Lock Corp.
Yeah, thank you very much. I appreciate the opportunity to tell you a little more about what we're doing here. My name is Scott Larson. I'm the CEO. This is my third startup. The last two were satellite space companies. The first one we took public, raised a couple $100 million. And second one, we launched 2 satellites and then sold that to a US operator. We started this company about 3 years ago, based on 8 or 9 years of academic research, science, R&D, mainly out of Western Canada. And we have put together a set of technology, IP, patent pending capabilities that allows us to take CO2, carbon dioxide, mix it with water like a club soda. We take that carbonated water and inject it down into a mineral called brucite. And when this carbonated water hits the brucite, there's a chemical reaction in that the CO2 begins to mineralize, crystallize, and effectively turns into stone. So you're taking the CO2, mixing it with water, put it underground, and it is staying down there forever. So when you think of CCUS, we are the S, only the storage part. When the company started, we identified about 300 locations around the world that have the right geology. Our first one is in Western Canada. It's about 50 square kilometers in size, and it has enough geology to store about 1 million tons of CO2 per year for 25 years. So that's the size of the sponge. We're under LOI to start another couple sites, and we'll certainly never get to 300, but that's the size of the scale. Our revenue model is kind of broken down into 4 or 5 different buckets. First would be working with the emitters, with the producers of this CO2, which are based about 50 kilometers away from where our site is, mills, refineries, factories, taking the CO2 from them, putting it underground, creating tax credits, government incentives, and then splitting the economics with them. Secondly, we will take the risk on from the CO2, we'll buy it, put it underground, and then create a carbon credit that we own and sell that into the voluntary market. Third, joint venture partnerships. And then fourth, storage as a service. So working with large energy-type producing companies that are looking to create offsets, going to them and saying, you can create offsets here, we put the CO2 down for you, you get to claim it towards your net 30, your 2030, 2050 targets. This is the size of the market. It's not a huge market right now. It's about $1 billion. It's growing at about 40% compound annual growth rate per year. Within 5 years, it'll be about $5 billion and get up to about $15 billion over the next kind of 10 years. It is fluid, of course. So the company started, we spent about 18 months doing research, R&D work in the lab. We did a pilot project, drilled a hole to check the geology, put down the first batch of CO2, identified the other sites for scale. Moving forward, this fall, we're going to do phase 1. We'll put down 200 tons of CO2. Next year, scale that up to about 25,000 to 30,000 tons, which is a decent amount. And then we'll scale. It'll take 5 or 6 years to get up to 1 million tons per year. We're doing a round of financing this summer, raising a early A, late stage seed. We're going to raise another $5 million. Thank you very much.
Thank you, Scott. So how do you assure the sites? I mean, do you own them? Do you lease them? Do you develop them in collaborations with any administrations? Or how do you do it?
It depends where the site are. So every country, every jurisdiction has a different kind of regulatory environment. The one in Western Canada, where we are, is probably the best in the world for this type of thing. So Canada has a very well-defined structure, regulatory environment for getting access to the resources underground. Different parts of the world, the US has a different one, other parts of the world have. So for this one, it's secured. Tenure rights, mineral rights, access, that's fine. But that is a process for sure.
Can you comment on the cost per ton as you store it, and maybe then the cost of the associated carbon credit when you're fully scaled?
So our cost to put a ton down is about $12 to $15 per ton. That's the drilling, that's the operating costs, and everything else. These type of credits, carbon credits are the most valuable. Right now they're selling for $300–400 a ton. We think that's probably high. In our internal modeling, we're estimating between $100 and $150 per ton. So if you think of 1 million tons per year times 100, that's kind of the revenue scope per annual revenue capabilities, $100 million a year.
Thanks for the presentation and your answer to the cost. Just want to understand how your model or the brew site that you're targeting is it efficiency versus peridotite and basalt, and is your competitive advantage more driven by the low, I guess, relatively lower cost, if a lower efficiency?
So if we were to do this in the lab, take kind of pure brucite mixed with CO2, the reaction time, you can almost see it with your eyes. Like within a couple days, it starts to crystallize, mineralize. It's very, very fast. Underground, it's 90% within 9 months, 100% within kind of 12 to 15 months. So it happens quite quick when you talk about a geological, about a million-year time frame. Other companies are doing it, different geology. This is better. It's faster. Does it make a huge difference? I don't know if it does. Our IP is in kind of how you mix the water and the CO2. It's kind of dissolving, which is unique, and then how you monitor and measure and report that the CO2 has been mineralized. That's kind of where the main buckets of IP are.
Thank you very much, Scott. That would be all. Thank you. Please let's welcome Emil Dalsgaard, CEO of Klimate Apps.
Hello. We don't make apps, it's just APS, it's the LTD of Denmark. Great to see you all. I met one of my investors earlier this morning. I hope you're a little bit more fresh than he is after the festivities last night. My name is Emil Dalsgaard. I'm from Climate.co, and let's kick it off. We started 4 years ago, me and Katja and Simon. My background is as a serial entrepreneur. I've studied at Copenhagen Business School and the IT University, so mixing those skills. Katja, my co-founder, is a management consultant by background, was in BCG, and Simon is a climate scientist, so he wrote a PhD within the space that we're operating. And now we're 22 people, mostly based in Copenhagen. So we are in the carbon removal space, and I think you already heard quite a bit of this, so I won't spend too much time on it. We all know that it's a massive opportunity, and even in the market that is a bit uncertain right now, we do see that it's growing really, really rapidly, and 75% of the world's 2,000 largest companies have already made some public commitment that will require them to remove CO2. Are they all going to deliver on it? Doubtful, but it's definitely going to be a big market, and it's already growing fast. We need to remove CO2 because without removing carbon from the atmosphere, there simply is no way to get to zero, and we need to get to zero if we want to have a good time living on this planet. But how do you remove CO2 from the atmosphere? We've already seen several examples of it today, but I just want to talk about some of the strengths and benefits and how they differ. You probably all know reforestation. There are many kinds. Like the benefits is that it's fairly cheap and it's quite scalable, at least for now. And the co-benefits are very high. However, it's not very permanent. On the opposite side of the scale, we have something like direct air capture, which you just heard of. It's a very permanent way to remove CO2, but it's also quite expensive. I think the prices that were just mentioned are quite optimistic when we look at the offers that we see. In between, you have something like biochar, which has maybe a bit of a sweet spot moment right now. But let's get into what we're doing at Klimate. You might think that it's very simple when you buy carbon removal. You just connect a buyer and a seller, but actually there are a lot more players in the market. You have the registries where the credits are issued, you have the MRV providers, and as a buyer you need to engage in all these. You need to do due diligence on the projects, you need to retire the credits in the registries, and you need to collect data for reporting, whether it's CSRD or something else. And all of this compounds as you start buying from multiple projects. It gets more and more complex, there's more and more data to manage, and companies are doing this in spreadsheets, and it's a big risk for them. At Klimate, we combined all of this into a single digital solution, so we're the software layer between the complex market and the buyers, and we do the project sourcing, due diligence, we do multi-year contracts, we can retire credits using APIs, so we can do it in multiple different registries at once, and so on. We have super good traction, if I should say so myself. We more than doubled in gross revenue last year. We have a very low burn, so we're 22 people, we're only burning around 90,000 euros per month. And really our go-to-market has been super efficient because we work together with partners, so we don't do carbon accounting, but we work with the carbon accounting platforms. It also means our revenue is very global, even though we're started in the Nordics. We are a fairly international team, client base, and here you can see some of our clients. And I think that is it from me. Only 10 seconds over time. Go ahead.
Thank you for the presentation. A quick one, how difficult is it to build exactly the same offer and start competing with you?
I think in this market, scale really matters. Like where we make the money is that we are sort of big enough to procure large amounts of CO2. So this is like one blocker to entry, right? There are a lot of companies who have popped up while we've been doing this and gone away. We're sort of in the top 10, 5 globally in carbon procurement. So individually, we are bigger than any single buyer, right? So I think this is part of it. And then the software underlying it, it is actually quite complex. Carbon assets are not fungible, right? You can't just replace one credit. So we need to be able to track an individual asset all the way from the specific delivery in the project to the specific tranche of an order, right? So I think the software component is also there.
Thank you. I think you're raising 8 million. Can you talk a little bit what you're going to use those funds for?
Yeah, absolutely. So I mean, there's nothing sort of huge strategic shift in what we're doing. So it's basically just scaling. We are opening up an office in the UK. As you could see, like 40% of our revenue in the last 12 months is in the UK, but we don't have anyone on the ground. And then we also just want to beef up the product team, right? We have made the first API integration to a registry. We want to add another 5 in the next year. We have the first MRV provider integrated. We want to add at least 5 also in the next 2 years. So this is sort of just building our product and growth.
Just really quickly, can you walk us through your revenue model?
Yeah, of course. So we make revenue on both sides of the transactions. So on the client side, it's basically depending on how large the client is. So we have a service fee on top of all the credits that the client is buying. And of course, for bigger clients, that is reduced. And then on the supply side, it depends on the contracts that we can negotiate with the individual projects, right? So to the other question, we are a fairly large buyer, which means that we can get a lower cost, and we pass some of that cost on to our client, but not the entire cost. And we are also rolling out, because one thing we've seen in the last year or so is that we're starting to have clients that have bought CO2 capture before they met us, unfortunately. But for them to get access to the reporting, the management, the retirement, all of this functionality, we can make the transactional model, so we're rolling out a SaaS as well.
Thank you very much for your pitch,
Thank
you. Please. Okay, big applause please for Florian Tyler, co-founder and CEO of Ucaneo GmBH. Oi, oi, oi. That's a scary step, start, yeah, no. You'll do fine, don't worry.
Yeah. Okay, cool. Nearly tripped, anyway. Thank you very much. It's very nice to be here. And I'm Florian, co-founder and CEO for Cano. At Ucaneo, we develop a new direct air capture technology, and not only the tolls are making this world burn, it's also climate change, it's still there. We have to remove billions and billions of tons of CO2. I know everyone here probably knows the problem, but we've heard a lot before. There's also technical solutions like direct air capture. However, it's very, very expensive. But if we're actually going to make it cost effective, we have a huge market, a lot about the future of production, so producing any kind of carbon neutral or carbon negative products, or basically helping you to manage, like any kind of corporate, individual, organization, to manage your carbon footprint. What we do at Ucaneo is we're developing a breakthrough electrochemical technology mimicking actually the human lung. So that means, I know a lot of tech companies always saying we're the cheapest, we're the best. We actually did a feasibility study with an external consultancy showing we can already reach cost of below 300 euros per ton of CO2 in the upcoming years, because it doesn't help you to tell everyone we're going to be below 100 euros, but if it's in 10, 15 years or the 1 million ton scale, it doesn't help anyone. So we know we can reach this cost already in a few years, which make it to one of the cheapest solutions in the world. How we do that is the secret sauce is basically combining an electrochemical process with bio-inspired materials. So it means we're not always binding and breaking the CO2, we're actually just bubbling it in with pH and bubble it out again. This allows us to reach significant cost savings and energy savings. And one which is very, very exciting for our investors or companies we're working for is we can work with very intermittent energy, so flexible energy load. That means you can ramp it up and ramp it down very, very quickly, allowing you to leverage actually negative energy prices or flexible load. And that's something quite exciting. From the team side, we're roughly 22 people. We're based in Berlin and have a lot of mix. We just announced an investment from Saudi Aramco. We have one of the first employees from Climeworks on our board and a lot of actually R&D experience. We are currently on track to build the largest DAC plant in Germany. We actually also have quite a nice capital stack, which is quite efficient so far. And this will actually be built directly in Berlin. There will be like our flagship plant. And then we're also building a huge first of a kind, which is more commercially optimized by end of 2027. We actually just received in the last 3 weeks more than 6 million euros in grants. And that's why we're here today. We're actually looking for roughly 3.6 million euros, just helping us to ensure liquidity to actually build, as mentioned, these 2 first-of-a-kind plants. We really look about building a very strong financial and industrial syndicate. And we've already, since we did our round in June last year, had significant traction by filing 2 more patents, scaling up the technology by more than 100 times. Thank you very much. And yeah, would love to work with you on the forefront of carbon removal.
Thank you for the pitch.
Thank you.
What is the proprietary technology of your system?
That's a good question. I mean, we do an electrochemical approach, which is basically we have 3 parts of where we file IP or have a lot of IP. One is the process, because it's a new process how you develop. The second is a lot about the solvents, because with the solvents you're reducing significantly the energy load and the capex factor, because the main capex driver are the membranes. And the third one is actually the cell design. So we actually have 3 parts where we create a lot of IP. And one we filed for the process, and 2 others are currently in process, which is the cell design and the solvent, because we're currently getting industrial scale data, and then we file. Currently it's trade secret.
Thank you.
Hi, thank you for that.
Hello.
Can you talk a little bit about your revenue model? You know, some of your competitors have sold
question.
forward. Is that your strategy as well?
Yeah, good question. We're not going to be, or we're not seeing ourselves, for example, similar to Climeworks, to do everything from beginning to end. We're going to be a technology provider. So in the beginning, we have to build the plant because no one loves your baby as much as you do. So at night, when you have to fix stuff, it's always you. So we pre-sold carbon credits, and we also did 1 paid pilot with a large oil and gas company. So at revenue of roughly 600K. And these pre-purchase or offtakes is just to finance the first grants to help, to help this capital stack. But when it's very, very large, and we work with, for example, Aramco or other large energy and oil and gas companies, it's more SPV structures and licensing.
"15 seconds. Any more questions?"
Yeah.
So if I'm getting it right, compared to your competitors, you're more operating like a bio plant in the end. Is it any harder to operate in the end than something like Climeworks, which is a mechanical machine? Been working in biology, sometimes things are unpredictable. Can you comment on that?
Yeah, maybe to highlight, so we're not doing any biological components anymore. It's actually mimics, so it's all polymers and stuff, so it's much more predictable. But how about running is a lot about how flexible you run, depending on the location, the energy source you have, to just pay off your capex. But this is a bit of a different topic. Cool.
Thank you very much, Florian.
Thank you.
That will be all for today.
Thank you. I will be careful here now.
Oh, yes, very careful. Sure. Thank you. Okay, introducing our last speaker of this session, Rait Maasikas, Chief Financial Officer at UP Catalyst. Okay, there you go.
Hello, nice to be here. I'm Rait, CEO of UP Catalyst. Did you know what is the dirty secret of EVs? To build one, it generates twice the CO2 footprint than building a regular gas-powered car. And who is the one to blame? Well, it's actually the battery. When we look into the battery, who is the one generating majority of that, a large part of that? It's graphite. Graphite generates about 1/3 of the CO2 footprint of battery. And graphite has two problems. First, we don't have it here, so it's mainly imported. And second, the way it's produced generates such a big environmental footprint. At UP Catalyst, we can solve both of these problems. At UP Catalyst, we turn CO2 emissions into battery-grade graphite and CNTs. I can actually show you that as well. This stone in my hand used to be CO2, an invisible gas. And with our technology, we can turn this into a solid carbon, and the CO2 is kept here for thousands of years. I can just show you as well. And this technology has two fundamental advantages. The first is this is one of the most energy-efficient conversion processes, and that comes mainly from the temperature, operating temperature. We run this process at temperature around 700 degrees with a cycle of 1 day, whereas the traditional ways of producing synthetic graphite runs about 3,000 degrees and for 2 weeks. This turns into, obviously, also into the cost side of the things. Just give you an example. To produce 1 kilogram of carbon nanotubes, our production cost is well below 20 euros. And the market price for this product is well above 100 euros. And we can do the same at scale for graphite and compete the current pricing from China. And the second thing really is that since we consume CO2 to produce this, then the footprint of the end product is also CO2 neutral. Hence, we can fix the problem of the CO2 footprint of the EVs as well. What do we need to that? Just two things, clean electricity and CO2, and we can basically do that anywhere, even on the moon if needed. We have a very strong team, 40 people, probably one of the strongest teams in this field right now to make this happen. To be relevant, we need also a large scale. For that reason, we are now about to build our largest industrial-sized reactor next year. And for that, we have secured just 2 days. We announced 2 days ago that we got 18 million funding from European Investment Bank, and we're going to pair that with Series A funding towards later this year. And also 2 weeks ago, European Commission announced 47 strategic projects under the Critical Raw Material Act, and we were one of those. So join us in this mission to create this local critical raw material resilience and fix the problem of CO2 footprint of electrical vehicles. Thank you very much.
Thanks a lot for your presentation. So what differentiates your solution from the number of others who also convert CO2 into the graphite?
Yeah, that's a very good question. We see the main graphite from petrol coke generating a lot of CO2. But of course, there are many other ways as well. But we see our sort of main differentiator, we turn pollution into a solution. So we don't have to take down more trees or other biomass. We can actually use the CO2 that is today going into the atmosphere, causing the global warming, and we can turn this into a useful raw material.
How do you guarantee the traceability of your graphite? I mean, like, do you have any independent company, or do you do it yourselves? Do you emit any carbon certificate of that graphite is from captured CO2, or how do you do it?
Yeah, we actually collaborate with typical biogas companies. They're actually not at the moment under the carbon credit market at all, so that's not really a problem at the moment for us.
Given the situation of the European battery industry right now, so can you comment on the market size or the potential market size for your graphite? Is that a problem, or?
Yeah, I mean, it's a typical sort of, it's not this rolling out new technology never happens like linearly, so that's indeed we see like a little bit lower space in the EV side, but at the same time also the stationary is something that where it's really necessary to find these storage solutions, and batteries is one of the only solutions right now.
Thank you very much. Right, that would be all for today.
Thank you so much.
Congratulations for your pitch.
the ESG reporting is dead. You see that companies pulling out from it, so the regulators, and honestly, it's a good thing, because sustainability turned into compliance. You can easily see that in major companies, sustainability teams spend 80% of their valuable time filling these forms, sending it to each other. And what's bad about this is that it's absolutely disconnected from reality. Teams focused on copy-pasting data from document to document, not connecting it to what matters for the business, for their shareholders, for revenue, for real decision-making. And this disconnection actually is a massive problem for heavy industries like metals that actually powers energy transition, tech, defense. This cost is massive because they cannot operationally take decisions to make important improvements because teams are busy copy-pasting the data. That's why we built BeSerious. With BeSerious, we replace static reporting with what we call sustainability twins, living sustainability twins. It's an engine that captures all the data from companies' sustainability documents, you name it, reports, policy certificates, etc., and all the practices, and then make it reusable. It can fill any template, respond to any question, benchmark against any requirements or any standard, and gives and provides insight. At the core of our solution is what we call, you can think about it as adapter. So we have all your data, and we can transform it to any requirement that is needed, being it banks, customers, suppliers, rating, etc., etc. But it goes far beyond this. And what's important is that it can understand what your clients are asking actually about, what's important for them. And this gives you unique knowledge about how you can tailor your product to them. And this connects it to revenue. And it's working. We already work with major companies, major metals and mining companies, and actually here should be one energy company, not yet today, not on this slide, but it's already our client, and they love it. Their team spent up to 30% of their working time on the platform, saving a lot of time, getting a lot of valuable insights. Our team comes from the industry. We know this industry deeply. We spent 20 plus years in metals and mining, building tools for leading companies, as well. And once again, we are not building another reporting solution. We are building the data infrastructure for the whole value chain, from mine to OEM. And we connect sustainability twins to each other, making them talk and making sustainability strategic operational. Let's be serious.
Thank you very much. Yeah, you can go with the questions.
Hi, thanks a lot for the presentation. So to make this whole thing work, you need to bring a lot of different players on board them onto this platform, right?
Not really, because we start working with one company. That's the vision. The last slide is the vision, that we connect them. But for company to benefit from BeSerious, all they need is all your data on the platform, and then you extract it in the way you need. So the vision to work, we will, you know, we need the companies to be on the platform. But for you as a single company, you don't need others to benefit from it.
So what is the core value, key value that I can already benefit today from this product?
If you are coming from the industrial company and you have sustainability team, you dramatically cut the time that they spend on reporting, on disclosure, and on gaining analytics to fit, to shape your product, how you address your customers, or maybe what you tell to your shareholders.
45 seconds to go. Any more questions?
Yeah. Can you tell more about the revenue model? How much do you charge? How do you charge?
Yeah, revenue is quite simple. It depends on the usage. The more company use the tool, the more they pay. So it's, if you don't use, you don't pay. It's an AI-driven model, so it's I think it's quite typical in this AI world.
One more question.
Thank you for the pitch. My question would be: are you currently fundraising, or are you having an open round?
No, right now we're not looking for funding. We actually closed our round in last December. So for now we are good.
Okay, in which stage are you?
We closed seed, and maybe we'll be raising Series A closer to the end of the year or 2026.
Perfect, thank you.
Okay, that will be all for today. Thank you very much.
Thank you.
Congratulations for your speech. Let's continue with Sim Vips, CSO and co-founder of Bisly, Scalable Building Automation. Good luck.
Hello. Henry Ford made cars affordable, but at the same time more reliable. How was that possible? Through standardization. And this is what Bisly is doing with the building automation industry. We all know that buildings are consuming the most energy, and at the same time we know that building automation reduces 30 to 40% energy costs, but it's seldom used. And in fact, 95% of the buildings are not automated that well, and the ones that are don't work properly, and this is just sad. Billions are being wasted. And we realized that 80% of the building automation deployment cost is overhead, and it's being done by the local integrators. And it's much like coach building business was back in the day. It's just not scalable. So the pain is there. What are we doing about it? So we have developed and patented a single cloud platform which is working harmlessly together with our hardware suite. And it's also connected with the third-party equipment. Universal Digital Twin is used in sales, installation, commissioning, and support. And this allows to push the cost down, quality up, and maximize energy savings over time. And most importantly, it allows to scale to a wider installer base. The platform is designed from the cloud to hardware, meaning that we are able to keep all the buildings on the same software version. And this allows to keep the operational cost at bay. And at the same time, believe it or not, our hardware also scales. We have a dream team who is no stranger to building Estonian unicorns, and we are on a mission to building the next one. We are already dominating the local market, so we have actually grown the Estonian market 10 times, but the Estonian market is small. So at the moment we are focusing on scaling through channels in DACH region and UK market, which are established markets for us. And I really believe that building decarbonization to reducing carbon emissions from building is like a hidden opportunity and the possibility to save billions. Thank you.
Thank you. Thank you for the pitch. I think we've seen quite a lot of building management systems in around the sort of climate tech ecosystem. What do you see as your key differentiation point against the competition?
No, the thing is that our solution has been built from ground up with a mission to fill the gap of this 90% of the market who is missing out, meaning that we have built the system from ground up to reduce the costs as much as possible and making it scale so that you don't need to be engineered to sell, to install, and to maintain the solution. So it's like a standardized approach which is dramatically reducing the costs and enabling the deployment for the wider market.
Could you expand a bit on your go-to-market channels, or do you leverage any partnerships, or do you go directly to clients?
Yes. So initially the go-to-market was foot on the ground to come up with the best possible product. Then last year we transitioned to partner deployment, and now we're transitioning to channel sales as well. So basically channel-driven sales using not only automation engineers but security companies, low current companies to expand their business.
30 seconds. Any more questions?
Give us a sense of the kind of cost-saving potential.
So the cost savings, if you take the energy cost, then it's the same as it would with traditional automation, but it's just much more affordable. The closest competition is at the moment at least half more expensive. So we try to keep the capex cost for the buyer at the same level that they would pay for the stupid building, and this is helping us to scale rapidly. And then one more thing maybe to add is that we have really strong unit economics. And for every euro that we make on a hardware, we make 3 euros down the line on the software. So it's like a sustainable model. So we are scaling with the high margins.
Thank you very much, Tim. That will be all for today.
Yes, thank you.
Okay, let's receive on stage Doron Tamir, CEO of Lava.
Okay, so hi, Doron. 20 years in the renewable business. This is my second company. In my first company, I was a big developer for solar and wind. And then I came to the conclusion that solar, wind, battery is very nice. It can be part of the solution, but not the solution. The solution needs to be baseload, dispatchable, and stable. So, and we decided that the heat can solve the major challenges that we have with net zero. But the problem with heat is the red line. It's called isentropic expansion, and the meaning that when the gas is expanding, it's cooling down. It's not important, but this is the most inefficient way to have power. With isentropic, actually, turbines, steam turbine or acid turbines, gas turbines, air conditioning, heat pumps, all of them lying on this red line. This is the most inefficient way, and this is the only way. What we succeed to do in Lava, we develop a new thermodynamic cycle, the first to be isothermal. So now we can be much more efficient than the existing solution. So we can have new turbines, new heat pumps, new air conditionings, new compressor. All of them with much better efficiency and with lower price. So what we develop, it's a new thermodynamic cycle, and we are the best to convert heat to electricity and electricity to heat and cooling. Heat to electricity, heat engine, electricity to heat and cooling, heat pumps. Just to understand the power of this thermodynamic cycle, so if today we have 4,000 gigawatt of steam turbine around the world, with our thermodynamic cycle, we can generate 5,200 gigawatt. So the delta, it's 1,200, which is double of the US consumption for electricity. You can have a lot of application from long duration storage to heat pump for 200 degree to cooling of data center, to replacing gas turbine, to industrial waste heat. You have many. We're starting with cooling of data center and with waste heat. This is the beachhead. These are the two machines. The first one is the heat engine. The second one is the heat pumps. This is our first operational heat engine. It's already operational, fully operational, and we already achieved 80% from Cano efficiency, okay, which is a world record. Till now, we've done our seed round, and we raised 20 million and another 5 million as a non-dilutive. Lately, we won the EIC in Europe, which is the most prestigious competition in Europe. We already have partners in the steel, in the data center, in the cooling, in utilities. All of them are T1. And next year, we're going to be fully commercial. So this is the EIC, what the juries think about or thought about our innovation, and what we bring actually to the table. If I'm right, we can change all the energy market. Thank you very much.
Thank you, looks impressive. We need to rate here your team, so you didn't say anything, right?
So today we are a combination of excellence between the academy, leading by co-founder Professor Kamil Rothschild, which is 100% of his time in the company, which is very rare to professors. Okay, so we take several years off from the university. We are almost 40 people today. Most of them are engineers. So this is the team. And what is actually also important is that part of my team, Ormat is the world leader for geothermal and ORC turbines. So the VP engineering of Format, the VP project of Format is now with us.
Can you briefly lead us through like the mechanical implementation of your process? Because I mean, there's other, for example, you can build a Stirling engine, which is very efficient, but not scalable and not very But so, what's the secret sauce? What do you actually do to implement it?
Yeah, just to if we are speaking about Stirling, in the end of the day, Stirling is not isothermal. No, principle it's isothermal. Practically, it's not isothermal. Okay, it's adiabatic, but if you what happened? What is the problem with adiabatic or isentropic? That when the gas is expanding, it's cooling down. This is the base, the problem. What we done, we developed a new nozzle. It's just a pipe. Okay, so we take the heat. We doesn't care what is the source of the heat. It can be geothermal, it can be waste heat, nuclear, whatever. Okay, cold fusion. Okay, but we're taking the heat and warm up our liquid. The liquid is regular liquid. Okay, so we have the hot liquid is going into the nozzle, and then we inject another liquid. When it's going in, we have evaporation. So we have evaporation, so the liquids become to bubbles. Okay? When it's become to bubbles, if it was on the red line, it needs to cool down. This is the basic principle of gas. Expanding, cooling down. But in our case, all the surrounding, it's hot liquid. So because of the surface of the bubbles, they suck the heat from the liquid, so they are not cooling down, so they continue to expand. This continue to expand, this is exactly the moment that we move from the red line to the blue line, from isentropic to isothermal. And this is, then it's going out in a supersonic speed. We just took 6 nozzles of this kind, and it just rotate like a sprinkler. Okay? Heat, kinetic, electricity.
Thank you very much, Doron. We run out of time, so congratulations for your pitch.
Thank you.
That would be all. Time to listen to John Fox, Chief Operating Officer at Natrion Inc. Good luck, John.
Thank you. Right, good morning, everyone. I'm going to talk to you about something that's inside every single battery. It's a piece of plastic, often referred to as a separator. Separators today are benign. They do nothing but keep the positive and negative parts of the battery apart. We have a problem with batteries because when they get hot, this piece of plastic melts and that creates a thermal runaway. And because the battery is relying on a liquid to transport the ions, that liquid can catch fire, and that's when we have all sorts of problems. The elephant in the room is actually the supply chain of separators. It's 91% dominated by the Asian market. We have invented a new polyethylene that is a drop-in solution that drops straight into existing gigafactories, and our material starts to become smarter. It acts as part of the actual battery, and it starts to get into the world of solid-state batteries, but today it also enables batteries to operate in a more efficient and energy-dense way. Without going into the detail, we can add 15% to today's batteries at an energy level without changing anything. So you turn up at a major gigafactory, you tell them you're going to make this improvement, and they put their hands up and say, we're not changing our process. The good thing is our material just drops in. They don't need to change anything other than use our rolls of material. The next thing you're going to ask is, well, it's bound to be more expensive. Well, funny enough, it is. But because of the 15% increase in energy performance, at a bill of materials level, we're 9% cheaper for a kilowatt hour of energy when they measure it at the cell level. What does that mean in real terms? It means your iPhone can start to use materials like lithium metal. Again, lots of other reasons why you can't use that today and why we can use it with our material. But you can see straight away, if someone adds 7 hours of additional charge time to your iPhone, you're going to start listening. Our goal today, we have a small pilot line that we've been using for the past year. It was repurposing equipment that was used previously by IBM. We've worked out how to make this in volume. We've placed orders for our first production machine, and we're going to be at 1 million square meters by the end of this year. We're talking with 4 of the top 15 OEM manufacturers for EVs, one of the major ESS players. We are a prime defense contractor in the US, and we're talking with the markets for consumer electronics. We've got a very strong team, we've got proven people, but more importantly, we're raising a 10 million Series A. We've got probably half of that agreed, and we're looking now to unlock additional opportunities within the VC markets. Thank you for your time. I'll take any questions.
Thank you for the presentation. Seems like this innovative solution has a lot of benefits, but you mentioned one that caught my eye a lot, the economical challenge you have. How the challenges right now we have with supply chain volatility affect your solution, and again, when it's not attractive by itself without this volatility.
So supply chain's a big, big challenge in this marketplace. As I said, it's dominated by the Asian players. It's a push and pull requirement. We're engaging with the battery users because they will tell the big OEM manufacturers of cells that they want our product in their batteries. We're also talking to the battery manufacturers, so we're pushing and pulling both ends of that scale. It's a huge market. It's billions of square meters of material. Are we going to dominate it? Unlikely. Can we make millions of square meters? Yes, because the machinery can. It's a rinse and repeat model. However, we're then into the world of licensing and other discussions around M&A. So the longer term is you have to prove it, you have to show its manufacturability, and then the rest is conversations.
Thanks for the pitch. How compatible it is with current lithium-ion battery production lines? How easy is it to integrate it with those?
So again, it's about proof of concept. We have a small facility that makes cells. So we've taken our own cells to market and let people prove it. The graph I showed was actually independent testing from a major OEM who took our materials and dropped it into their own cells and came back with the results that we see, which is the 15% improvement.
Thank you.
Okay.
That will
Thank
be
you.
all. Thank you very much, John.
Thank you.
Congratulations. Okay, let's continue. Let's welcome Alessandro Minori, CEO and co-founder of Pipine. Pipine? Yes. Pipine.
Thank you.
Okay, thank you.
Okay. Good morning, everyone. I am Alessandro, CEO and co-founder at Pipine, a startup developing a robotic solution for pipeline inspections. In Europe and North America, there are over 50 million kilometers of pipeline, and many of them are approaching the end of their useful life. And this is why every year, over 10 trillion liters are wasted due to pipeline failures, and pipeline operators spend over 200 billion euros trying to fix this problem. And this happens because pipelines are invisible infrastructures. They are old, and there is not data about the actual condition. And so operators cannot properly collect and leverage maintenance data to prevent the waste of natural resources and disasters. So at Pipine, we are tackling this problem with our solution that is called Deep Diagnostic System. It's a solution composed of 2 parts. A submersible robot that inspects the pipeline from the inside, linked with a digital platform that allows operators to switch from the current preventive approach to pipeline maintenance to a more efficient predictive one. How does it work? We perform the inspections, then the data are aggregated with other maintenance data that are already owned by our customers. We create a shared dataset, we process it, and at the end of the day, we provide a final report containing the risk of failure of each pipeline segment we inspected. The total market, considering pipeline with diameter larger than 20 centimeters, could be valued at 50 billion, and the main industries are hydropower, water and wastewater network, manufacturing industry, oil and gas. Right now we offer a B2B inspection service that will evolve into a subscription-based model where the customers will pay a recurring fee for accessing the data on the platform, while the inspection will be provided at the discounted price. About the traction, today we are already working with some of the major European utilities. We just signed contract for 100,000 euros, and we project to reach 800,000 by the end of the year. And we are very happy because they choose us for inspecting and maintaining one of the most critical and difficult assets. Our technology can operate at higher pressures and for longer distances compared to the competitors. Moreover, our robots are easier to deploy in confined spaces, and we can give stronger predictive maintenance insight given to a powerful integration between the hardware and the software. Right now, we are raising a 3 million round to make piping 10 times more scalable and 3 times more capable. And we're actually looking for 1.5 million ticket because the other part of the round is already committed. Till now, we raised 800,000 euros. We filed 2 patents, and we developed a product that has a TRL 8. And we are lucky because we can count on a team of skilled engineers who believe that the future for sustainable infrastructure lies in robotics and AI. Thank you very much.
Thank you for your presentation, and seems like a massive market and interesting areas you focus on. Can you share a bit about how the actual robot can inspect without damaging what is going on? I know it's a challenge by itself, and maybe share a bit more the technology and the right edge you have behind it.
Yes, we leverage what is called non-destructive techniques. So we have different sensors, but for measuring, for instance, the corrosion inside pipeline, we use ultrasonic sensors. This kind of sensor work not in contact with the pipe, but allows to measure the thickness. And of course, if after a while the thickness is less than the nominal, then probably there is a problem.
Thank you.
Hi, thanks for the pitch. I imagine it's a slow-moving industry where you're moving into. How's the sales cycle like with operators of such pipelines?
Yeah, actually it is, because our customers are utilities, often public utilities. So there is a lot of call for tender, vendor qualification stuff. But what we see is that we develop a unique combination of the technology that allow us to inspect and to provide a solution to very challenging tasks that has not been solved since the 50s. So once the utilities see this, the sales cycle reduced a lot. Last year, it took us one year to close a contract. Now we see that after testing the technology in the field, after successfully completing some pilots, this time is reduced to 3 to 5 months. So it's slow, but it's improving.
Thank you very much. Congratulations for your speech. Thank you.
Thank you.
Okay. Let's continue with Mark Verhagen, CEO and co-founder of Rift.
"6,000 industrial plants across of Europe cannot decarbonize. They want to, but they cannot. Even considering hydrogen and electrification, often the prices are too high or the infrastructure is not there. I'm Mark Verhagen, CEO and co-founder of Rift. And we bring a third alternative to the table, iron fuel. Iron fuel is a fuel which is completely grid independent, safe and carbon free, which is burned in an iron fuel boiler system in a plug and play kind of manner at the customer facility to create clean industrial heat for a cost price lower than those of fossil fuels. We're focusing on the industries which have the highest industrial heating pricing, food and beverage, paper and pulp, and special chemicals, 5 megawatt boiler systems installed. A customer buys an iron fuel boiler system from us with a 15-year contract on the iron fuel take-or-pay conditions. This fuel is coming from a Rift-owned iron fuel production locations. Therefore, our business model is quite similar towards the petrochemical industry. One fuel location provides multiple boiler locations from its fuel. The partnerships are already there today. 4.5 years ago, we started off with a company. From the lab, we went to bench scale, towards industrial piloting, prototyping, and currently we are at the demo scale. Those systems are operating on a daily basis in industrial context, and this is the last testing system that we will build. Now we are moving towards commercial implementation, with already 2.8 billion euros in LOIs contracted, and also contracts in the pipeline to be announced. The implementation will be around 2027, and we will do this with this amazing team of 60 people, which we have in the team, and major corporate partners supporting us. Our previous investment round was led by PGGM, one of the world's biggest pension funds in the world. And we will be starting raising in the next 3 months again to realize the first fuel plants ever in the world. Those 6,000 plants which cannot decarbonize, we can help them decarbonize. Iron fuel is real and able to scale today. Thank you.
Thanks so much for the pitch. You said you're planning on fundraising again. Can you tell us a bit more about like the upcoming round and what would be the use of proceeds?
Yeah, so it will be our Series B. And the Series B will be structured in one part on topco level and already pre-commitment of the fuel plant. The topco level will be 30 million and the fuel plant commitment will be 80 million.
Can you take us through your business model and kind of I mean, you said about the business model before, but the kind of margins. I mean, energy is typically a low margin business in a sense. So what is your cut on this and is it comparable? Is there a green premium in it?
Yeah, so from a customer perspective, the customer implements an iron fuel boiler system cheaper than natural gas pricing. So from the customer perspective, there is an energy green premium. On the boiler system, we make a 30% margin, equipment based, 2.5 million euros, 30% margin. And on the fuel, which is delivered for 15 years with the take-or-pay, a 15% margin will be charged. And the total fuel contract, depending on the customer, is 50 million until 100 million per customer.
"30 seconds to go. Any more questions? 35.
Thank you. Oh.
Just then the economic follow-on question. So there is no free lunch. So how can you provide a fuel? You obviously have to regenerate it somehow and you need the heat for it. So how can you regenerate that and at the end provide energy at costs lower than the natural gas? Like where do you take that energy from?
Yeah. So during the combustion of the iron fuel, ashes are created, which is iron oxide, that is transported back towards the fuel plant, which is regenerated with a low carbon hydrogen at the fuel, producing iron fuel. But we can dive into the economics way deeper if you are interested. Yeah.
Okay, time's run out. Thank you very much. Congratulations for your speech. Okay, let's move on and welcome on stage Fridolin Franke, co-founder and chief growth officer at Solar Materials GmBH.
Yes.
Thank you.
Thank you. Yes. Hi everyone. My name is Fridolin. I'm one of the co-founders of Solar Materials, and our mission is to transform the solar industry into a circular economy. Solar panels are the fastest growing electronic waste stream globally, and right now there's a lack of infrastructure to recycle these solar panels. And this is mostly due to the lack of a sufficient technology to really recover all materials from the solar panels. What's currently happening, beside what we do, is classical recycling approach of shredding and sorting, and with that you can recover the glass, the aluminium and the copper, but you cannot really recover the functional materials of the solar cells, so the silicon and the silver. And with that also 50% of the raw material value is lost. This means that the recycling is quite cost intensive, and this leads also to solar panels landing up in landfills instead of being really recycled and the raw materials getting back into the circle. Our focus is especially on the recovery of the silver as key value driver. And what we developed is more like a reverse production line where we focus mostly on mechanical process steps so that we have a lower capex and also opex compared to, for example, chemical processes, and we don't have any bad environmental impact. What we developed is more like a hub system so that we can do the pre-processing at several locations spread over Europe, where that we can reduce the logistic distances for our customers, reduce their logistic costs, and secure a lot of volume. So just last year, we established ourselves as number 2 in Germany already with over 6,000 tons, so that's 600 truckloads of solar panels contracted. All of these solar panels contain around 4 to 5 million euros worth of raw materials. We are 3 co-founders. We are young co-founders, we know, but we have really a lot of speed with everything what we do. So we founded the company like 3.5 years ago and went from really demonstrator stage to the first industrial recycling line, which is right now in the final commissioning phase. So we already process with that industrial recycling line like 1 truckload per day, and we'll ramp it up until end of the year. And then, due to the large demand from the market, we plan to further increase our recycling capacity. In total, our team is now over 40 employees, and we established a middle management so that we get more experience on board. So we now have head of finance, head of R&D, and also site manager to take care of the recycling operations. Until end of 2026, we will increase our recycling capacity by 5x, so to 35,000 tons or 1.7 million solar panels per year. And with that, we will become Europe's biggest solar panel recycler. For that, we raised 28 million euros in our Series B round, whereof most of it, so roughly 20 million euros, is already fixed. And now we have an open ticket, co-lead 5 million to single lead, like 8 to 10 million euros left. With the funding, we will increase our capacity at our site in Magdeburg in Germany and also establish a first recycling plant in Italy, a second largest market for solar panel recycling in Europe. The plant in Italy will be established as a joint venture as first step to a more like project financing approach so that later on we can grow more asset light instead of financing all recycling plants on our own. So the joint venture partner is a large asset manager, and they take care of 50% of the capex right now already, and then the plan is to raise a further fund for the global expansion of our business. Thanks a lot.
Thank you so much for the pitch. Can you talk us through your business model and maybe also mention a little bit about the key partnerships that, maybe if you can, you work with already?
Happy to do so. So we have a two-sided business model. We offer the recycling as a service to large solar park operators or collecting schemes. So we charge a recycling fee, which is a bit below market price. The big advantage of our technology or our business is that we would be profitable without that recycling fee. So to really secure all volume, we can basically offer it for free and still would make money of it. So on the input side, our customers or key partnerships are O&M companies and solar park operators. And then on the output side, we sell our raw materials to the industry, so to glass smelters, aluminium smelters, refineries. Welcome.
Thanks for the pitch. You mentioned you could potentially offer it for free as well, where for recycled panels. In what scenarios that would be the case, and where there is a cost involved, what is that sort of compared to current recycling measures?
Yeah, so right now our competitors charge around 100 euros per ton, and so that's like 2 euros per solar panel. And yes, large solar park owners are really price sensitive, so if we offer it like at 85 euros, then we get the volumes. And yeah, if we grow that aggressively, we could also offer it for free, because based on our raw material revenue, we would be profitable. So if it's needed at some point, then we would, of course, have a lower margin, but still can secure all volumes.
Thank you.
Welcome.
Thanks for the presentation, and it's great to see the market and your involvement during a short time. I was curious to hear, since there is kind of ambivalent and challenge also the emission during the recycles. Can you quantify your estimations? What are the emissions during this process?
Yes. So since it's a mostly mechanical process, so at some process steps we also use a bit of heat, but still low temperature. So per solar panel we consume below 7 kilowatt hours, and beside of that we don't have any gas emissions or anything. So yeah. So no real environmental impact.
No more time for questions. Thank you very much, Fridolin, and congratulations.
Thank you.
Okay, closing the third and final pitching session of this morning, Beltrán Berrocal, co-founder and CEO of Zero Labs.
Hello. Gracias. Thank you. Hi everyone, I'm Beltrán from Zero Labs. At Zero Labs we turn renewable energy from a complicated hardware problem into a very simple digital solution to accelerate its adoption, specifically by the Scope 3 supply chain of the world. And the other one, sorry, the big one. In the past 7 years, we built every kind of software for the energy industry. We worked with grid operators, multinationals, big utilities. We also worked at the Clean Energy Buyers Association with the chief sustainability officers that today are our clients. And we all know energy is the biggest problem, but if you look deeper, there's a huge invisible problem. More than 88% of emissions are indirect emissions caused by the supply chain or the use of a product in a company. So this is important. More than half of global emissions are hidden away in this category, untapped by decarbonization today, caused by the 400 million small businesses around the world. But for these people, I've manufactured with them and for them also, it's hard to take climate action. They don't have time, they don't have money, they don't have a roof where to put solar panels sometimes. They want this simple, stupid solution, and this is what we built for them. A SaaS solution that in 5 minutes decarbonizes 80% of their emissions, provably for all the parts. And with this new building block, digital energy, we built 3 tools, 3 solutions for now. A SaaS platform for the sustainability departments of large corporates to simplify their operations. What you're seeing here is a Fortune 500 managing with 2 PPAs, almost 1 terawatt hour, managing automatically 50 factories in the US. Something that it was taking them 4 months of 4 different people, we did in 2 hours, and now they can just simply see it flowing through and do more impact. The second thing, enhanced energy, enhanced by fractionalization and green proofs so that everybody can see it. And we found a new way to embed sustainability or clean energy into a company's products and services to turn sustainability from a cost into a new revenue stream for our clients. With this solution, we already decarbonized cloud and data centers, real estate, we experimented with batteries, we are experimenting also in the EVs and fleet space and charging point, we decarbonized events. And through a partnership program with Mastercard, we recently found out that there's very interesting opportunities to reduce finance emissions for banks and financial institutions. We already processed more than 3 terawatt-hours for more than 2,000 buyers around the world. And yes, clients and sustainability VIPs love what we're doing, and even PwC likes our automated reporting solutions. Right now is the time to act, even in facing the global political headwinds against decarbonization. More and more companies want to be net zero companies, and decarbonizing and helping their supply chain, small businesses use and adopt clean energy is the fastest way to reach to the goal. So we are fundraising, I can talk to you more about that, but whether you're a company wanting to accelerate your decarbonization or an investor, we'd be happy to help you get there. We invite you to join our mission to zero emissions.
Thanks for that. I imagine a substantial amount of emissions are coming from emerging markets supply chain.
Yes.
How do you deal with that?
Well, our go-to-market goes through the large corporates who deploy it in phases through that, but we are a global first company. If you have to open a new operation in a place that is not sanctioned, we can help you there, out of the box.
Thank you for the pitch, and it looks like you've made good traction to date. I suppose my question, we've seen a couple of startups in the Scope 3 emissions space. Where do you see the right to win? What's the most important product differentiation where you'll be a winner in this sector?
Yeah, so I briefly mentioned, I'm a designer. I had also a manufacturing company in the past. We worked with several around the world. I know how they think, and I've been speaking with a lot of them. And as a designer, I build a solution of zero friction for them to adopt, right? So that's one of the differentiating factors, first thing. But yes, if anybody wants to tackle the problem, that's the biggest problem of the sub-problem. So we are all welcome to confront solutions. The others, I don't know which one you specifically mentioned. If you want, maybe we can compare. But these people, they will act if their corporate asks them for. And after we gather that intelligence, we can help them on board onto the other solution. Maybe we're even working with some of the ones that you are mentioning to bring traceability into the mix as well. Thank you.
Thank you very much. Okay, and we are done. This is all for today. We are done with the pitching battles. Thank you very much to all the pitchers and also to the jury for your questions. The Energy Tech Challenges finals are done, and now it's time for lunch. So enjoy your lunch here at the hall and recharge your battery to follow up with the afternoon sessions. On this room, everything's done. Later on, everything will continue at the main room. From my side, everything, that's all, and thank you very much for your attention. Bye.